Section 3.3.5-T. The following data represent the high temperature distribution for a summer month in a city for some of the last 130 years. We want to treat the data as a population. We're going to complete parts A through C. So here is the temperature. So we have 50 to 59, 60 to 69, and so on, all the way to 100 and 109. And then the days, 2, 332, this is the frequency. We want to be able to approximate the mean and standard deviation. So in this scenario, we're going to use StatCrunch to be able to do that. So I'm going to open this up. Okay, we're going to open up our data in the StatCrunch. So I'm going to go ahead and do that. And then I'm going to come back to the screen here. Okay, so there's our data. Okay, now what we want to be able to do is we want to now be able to determine what is the population mean and the population standard deviation. So what we're going to do is we're going to go to Stat, and then we're going to select Summary Stats, and then we're going to go to the group bin data. Okay, and so the bins in are going to be the temperatures. The counts in are going to be the days. Okay, now we want consecutive lower limits, so we're going to select consecutive lower limits. Now this is where you need to be careful here. Because we're dealing with the population, we can find our mean, but then we're not going to use this standard deviation because this represents the sample standard deviation. Hold the control button, and then we're going to come down to here where it says unadjusted standard deviation. This represents the population standard deviation. So you're going to go ahead and select that. Now once you do that, we're going to go ahead and then copy down what we get for our information here. Okay, so if you take a look here, we're going to see that we get for the population mean, rounding it to one decimal place, we get 80.8. So this gives us our population mean. And then our population standard deviation is going to be, again, under the unadjusted standard deviation. So that's going to be 8.3. Okay, so now we have our mean and our standard deviation. Okay, now what we want to do is we want to draw a frequency histogram of the data to verify that the distribution is bell-shaped. Okay, now we're going to draw a frequency histogram of the data to verify that the distribution is bell-shaped. So we're going to go ahead and do that. Now, whenever we have the summary of data, StatCrunch doesn't allow us to kind of create a histogram this way. So what we're going to have to do is we're going to go to Graph. Okay, we're going to select Bar Plot, and then we have the summary. Okay, we don't have the data because we have the summary. Okay, so the categories are going to be in the temperature. Okay, and then the counts in are going to be the days. Okay, and then what we want is we want to create a worksheet. We want to make sure that the values are above the bar. And then we're going to go ahead and select Compute. Okay, so now a histogram, the bars would be right next to each other. In this case, this is a bar graph, so it doesn't represent a histogram, but it's very similar to a histogram. Okay, and so what we're going to do is we want to determine what is, or if this is bell-shaped. Okay, so if we take a look at this graph, it starts low and then it increases in the middle, increase in the middle, then it goes back down low. So therefore, this is bell-shaped. Okay. All right, now, in Part C, it says, according to the empirical rule, 95% of days in a month will be between what two temperatures? Now, approximately 68% of the data lie between the mu minus, or the population mean minus 1 times the population standard deviation, and mu plus 1 times standard deviation. Approximately 95% of the data lie between mu minus 2 times sigma and mu plus 2 times sigma. So already we know that we're going to have to use this version here. Okay, so since 95% of the data lie between those two values there, we're going to first find the lower temperature and the high temperature. So we know that the population mean was 80.3, and we also know that the population standard deviation is 8.3. So what we're going to do is we're going to take the population mean, which is mu, which is 80.3, or in this case I believe it is 80.8. So it should be 80.8. Let me make that correction there. So that should be 80.8. Okay. So we have 80.8. Okay. And then what we're going to do is then we're going to take the population standard deviation, which is 8.3, and we're going to multiply that by 2. So 80.8 minus 2 times 8.3 gives us a low value of 64.2. Okay, and then over here we have the population standard deviation, which again is 80.8, and then we're going to add 2 times the standard deviation, which gives us 97.4. So therefore, according to the empirical rule, the high temperature for 95% of days in a month will be between 64.2 degrees Fahrenheit and 97.4 degrees Fahrenheit.